Hi, I'm Trond Helge Danielsen. My background is 19 years within drilling and completion operations for both operators and service companies. I've been with 3M for 5 years and managed a portfolio of 3M advanced material solutions for the oil and gas industry. For example, 3M ceramic sand screens and a collaboration on lightweight drilling fluid, completion fluids, and cement. Today, I'm going to give a short introduction to our sand screen technology and some examples on how 3M ceramic sand screens can unlock the production potential in underperforming assets. Ceramic sand screens is a globally field-proven sand control solution to address challenges of premature failure of metallic-based filter media. The root cause of most sand control failures is erosion and corrosion. 3M has addressed this problem by using a material that is harder and chemically inert, so that it's far more resistant to erosion and corrosion experienced in the wells. Ceramic sand screens solve two key industry challenges. They reduce the commercial risk by increasing the reliability of sand control. Secondly, they reduce OPEX and CAPEX needs by replacing complex and time-consuming rig operations and minimize intervention requirements to repair downhole sand control. We now have a global track record of above 105 installations. Over time, rules of thumb or application windows evolve based on best practice and results. For example, in sand control, a fine contents above 5% would suggest a gravel-packed or compliant solution. These rules of thumb have evolved mostly to protect metal screens from potential erosion failure. Erosion potential is a function of material properties of the screen and physical and chemical properties of the reservoir and fluids. By changing the material properties of the sand screen, we change the boundaries of the traditional rules of thumb. This diagram compares the actual deployment history of ceramic sand screens by percentage of fines and sorting coefficient. The red and yellow squares show the application envelope for standalone screens and gravel packs. The blue square shows the actual environments ceramic screens are currently producing in. So, by changing the traditional design boundaries, operators can complete their wells using a less complex and cost-effective standalone screen completion, and removes production rate restrictions often required by metallic sand screen completions. Ceramic sand screen as a standalone screen can perform outside traditional erosion and corrosion boundaries. It can open opportunities for operators to exploit assets where reserves have been left behind casing and commercially challenging to approach with traditional sand control methods. Example, ceramic sand screens have proven in field where time-consuming and technical complex gravel packs have been replaced with a simpler standalone screen completion, or multi-zone rig-based workovers can be replaced with wireline, conveyed, stacked through tubing interventions. Today's case study is from Trinidad, where ceramic sand screens are used in multiple fields as a standard sand control solution to unlock production from thin bed reserves, which in the past was left behind the casing. Challenge. The thin-bedded reservoir sandstone experienced in Trinidad have a particle size distribution which is poorly sorted. It has a high fine contents, it's weakly cemented and prone to sand failure from day one of production. High production rates are expected from short production intervals, which raise erosion and hotspotting challenges. Rig-based solutions aren't viable in an economically challenging reservoir and were considered out of scope in this case. So, the solution. Earlier in the presentation, we claimed that we can provide reliable sand control in high failure risk environments and do so in a cost-effective way. In this case, reliable sand control was provided by ceramic standalone screens as a field-wide solution in conditions way outside any traditional survivability. For example, the current flux velocity is 100 to 120 feet per second in poorly sorted high fine content sand. This well has produced for over a year, whilst previous installations from last decade continue to produce. In terms of deployment cost and return on investment, Incremental production is currently 100 megascf and 3,000 barrels of oil per day from 8 wells, with no sand control failure. Deployment cost we kept feasible by deploying screens through tubing in a rigless wireline operation. Ongoing well surveillance also indicates that the skin factor after 1 year of continuous production was as low as 1, compared to a skin of plus 20 seen in primary gravel frac operations. In this case, lower cost of completion delivered higher returns. The solution has been strategically replicated in multiple fields to economically unlock production potential from thin bed reservoirs. Conclusions. Ceramic sand screens offers a simplified and reliable sand control solution that unlocks production potential in a cost-effective way from underperforming or marginal assets, with its ability to provide sand control outside the rule of thumb, for example, with high fine contents or high flux rates. Secondly, it's a proven substitute for internal or open-hole gravel packs, with a standalone screen completion that reduces the cost and operational risk. Finally, it reduces the operator's risk normally associated with primary and remedial sand control by solving the problem of screen erosion. And that's all I have for today. Please feel free to contact me anytime if you have any questions.